Welcome to VKS Coding. So today we'll talk about cash eviction policy. So before getting started with the cash eviction policy, let's first talk about the problem statement. So suppose we have a browser here and it is requesting some data from the web server. Okay, and that web server will call the first cache because that is a fast access memory, and whatever the data present into the cache that will be present into the RAM. So if the data is having in the RAM, so it will return it from directly from the cache itself. And if the data is not present into the cache, then web server will call to the database, and which is keeping the data into the solid state drive or hard disk drive. So that is a slower compared to the cache. Then the data will be returned from the database to the web server. Then web server will update the cache, and then it will return the data to the browser. So this is how the normal caching flow will work, right? So let's suppose there is a capacity in the cache is like 100 GB, and this particular 100 GB is full, and now we wanted to update the newer data to the cache, and we wanted to remove some data from the cache. So to decide which data to be removed from the cache to make the available room for the new data, right? So to handle this situation, we have a cache eviction policy algorithm to manage the cache. So first algorithm we have least recently used, that is nothing called LRU. So in this, suppose we have a cache size is 3. If the user is trying to access A at 9 a.m., then it is not present into the cache, right? So we'll fetch from the DB and we'll keep that entry into the cache for the further access, right? So the entry will be A for put into the cache. Next time the B will be try to access at 10 a.m. Then it is not present into the cache. Then we try to fetch from the DB and we'll keep into the cache for future references. Then when the user is try to access the C at 11 a.m., then again it is not present into the cache. So it will fetch from the DB. I'll put it into the cache. So now the cache size is 3 and we have all entry full into the cache. So now cache is full. Next time user is trying to access the D at 12 p.m., right? So now there is no space to keep the data into the cache for future reference. LRU says whatever the older data you are having, you can remove it. If you see the timing wise, first data came at 9 a.m., then 10 a.m., then 11 a.m. So the data which is older, like 9 a.m. data, can be removed and make available room for. So how the data will look like after the removal of A, then it will look like B will be first, C will be second, and D will be third item in the cache, right? So example of this kind of LRU is getting used in the when we want to cache the news data, right? So we wanted to serve the news data latest news, right? And we if the cache is full, we can remove the older data regarding the cache because that is not useful, right? The latest data people want to consume it. So second, we have a least frequently used. So here we have a cache size is 3, and initially it is having the data kind of A, B, C, and nothing is accessed as of now. Then first, when the user request come for A to accessing at 9 a.m., then in the cache the entry will be made as 1, like one time it is accessed. And when the second time the data is accessed for B, then we can make the count as 1 for B. When the user try to access the D, right? So D is not present into the cache. So we'll fetch from the DB and now we'll keep into the cache for future references, right? But which data, which entry should be removed, right? So according to least frequently used, we'll check the count of the each entry, and whichever having the less count, we can remove that one. So according to that LFU, we can remove the C1 and the data will be look like A, B and D. So this is how the data will look like after the removal of C. Now where it can be used, right? So it can be used for serving the viral content, right? Cases, suppose for particular video, a system will not get to know which is getting accessed more data, right? So according to the views, right, we can make the count of like A is having 1000 views, B is having 2000 views, like that we can increase the count of the particular views so that those entries cannot be removed because those are the viral contents, right? And whoever is not getting much views, we can remove the data from the cache. So third one we have a most recently used. So initially suppose the cache having the size 3 and it is empty, and when A is accessed by the user at 9 a.m., then we'll fulfill into the cache as 9 a.m. entry first one, and when the user access B at 10 a.m., then we'll put the entry in cache as well. Then user again try to access C at 11 a.m., then we'll put the entry in cache as well. Then the cache will become full, right? Now when the user try to access the D at 12 a.m., so when we fetch the data from from the DB and we wanted to push into the cache for future reference. Now the cache is full. We have to remove some data from the cache, right? So according to the most recently used, so whatever the data latest in this case, right? So the latest data is 11 a.m. at C. So that can be removed according to this algorithm, and this data will look like this: A, B, and D, and C will be removed. So where it can be used for Tinder, right? Whenever you do the profile for the left swipe, right? So you will not see again that profile, right? So you don't need that particular content, latest content after some point of time, right? So once it is accessed, you don't need for future sometimes, right? So whenever you cache this kind of a data, so you can remove the recently used data, means whatever the profile has left swiped recently, we can remove from the cache. So space will be available to put the latest data. So next one we have a FIFO. So FIFO stands first in first out. Let's check how it works. So initially the cache is having the size 3, and when A is accessed at 9 a.m., then we'll put the entry in cache first A. Then B is accessed at 10 a.m., then we'll put the entry for B. When C is accessed at 11 a.m., then we'll put the entry for C. Now the cache is full, right? When the D is accessed at 12 p.m., now the entries are full, right? So we have to remove some content from the cache so we can make the available space for storing to D for future references, right? Which content can be removed? So according to the first in first out, it says whatever the content comes to the cache first, we can remove that data. So according to that, we can remove the entry A. The data will look like this: B, C, and D. And where it can be used, right? So it can be used like caching the delivery order of the pizza, right? So suppose you have many orders like order 1, order 2, order 3, order 4, and you wanted to put the fifth order, right, into this cache. So what you can do, you can remove the first order, because when you serve the pizza, you will serve the pizza for first order, then second, then third, then fourth, right? So you have already served the pizza for first order, so you can remove this content and you can put the fifth content, right? So like that it will work. This is all about the cache eviction policy. So thank you for watching my video. Please do subscribe my channel to get to know more about the system design topics.